All right, for the next set of questions, let's try to figure out what we need to do. Just looking right here, 90% confidence interval. I can tell that this is a chapter 8 problem, interval estimation. And it seems to be a proportions problem because we have P. Okay, so now that we've determined that, let's read the problem and write out everything that's given to us. So in a random sample of 300, that means we have an N of 300. Let's write that right here. And then 300 students of class 2016, 60% were Americans. So we're going to do P bar equals 0.6. Okay. And then we need to construct a 90% confidence interval. Okay, so that's everything that we have. Let's start looking at this problem. First, I want to go to this cheat sheet right here. This is a proportions problem, meaning this is what we're going to be using, this right here, this bottom section, this proportions section. So to get our upper and lower limits, we need our point estimate, which is our P bar, plus and minus the margin of error. And to calculate the margin of error, it's critical value times the standard of error. This is the formula for standard error. This is the formula for critical value. And these are the two values that we need to calculate in these two problems. So the first question is asking for the standard error. So this is the formula that we're going to be using. So let's just put this to the side. It's the square root of P bar times 1 minus P bar divided by N. And P bar is 0.6. So I'm going to do the square root of 0.6 times 1 minus 0.6, all divided by N. Our N is 300. If you were to plug this in into Excel, you're going to get 0.02828. If you were to round this, you get 0.03. So the answer here would be C. Okay, the next thing that we need is the critical value. So how do we get the critical value when dealing with proportions? I'm going to go right here. The critical value is Z of alpha divided by 2. Okay, Z of alpha divided by 2. And Z of alpha divided by 2 is calculated with norm.s.inverse 1 minus alpha divided by 2. So let's put this aside again. And this is the formula that we're going to be plugging in into Excel. So equals norm.s.inverse. What is our alpha? Our alpha, let's actually do this right here. It's going to be, our alpha is going to be 0.1. And how do we get that? That's our 0.9, the confidence interval. It's 1 minus the confidence interval. That's going to be 0.1. That's our alpha. Okay, so we said it's norm.s.inverse 1 minus alpha, so 0.1 divided by 2. Okay, so if you were to put this into Excel, norm.s.inverse 1 minus 0.1 divided by 2, you are going to get 1.64. 1.64485. We're just going to round that to 1.64. Okay, so that's our critical value. There we go. That'd be the answer. I'm just going to put this as SE equals. Okay, so now to get our confidence interval estimate, we need to take our P bar and add and subtract the margin of error. And the margin of error is calculated by critical value times standard error. So P bar plus and minus our margin of error. So what's our P bar? Our P bar is 0.6. So it's going to be 0.6 plus and minus our margin of error. And we said margin of error is going to be our critical value times our standard error. So it's going to be 0.6 plus and minus critical value 1.64 times the standard error so 0.03. And if you were to do this on Excel, you're going to get 0.0, when you round this, it's going to be 0.05. It's going to be your answer. That's going to be this part right here, the 0.05. So it's going to be 0.6, 0.60, same thing, plus or minus 0.05. So that matches with this answer choice. Okay. Now it's saying, the next question is saying, suppose around the period, the above sample was taken. Suppose around the period the above sample was taken, principal of the school claims that 69% of all students were Americans. In light of the sample evidence and at the 10% level of significance, can we reject or not reject the claim? So what this is asking is, does this value lie within this range? So what we're going to do is calculate what this range is. So let's get our upper limit and our lower limit, UL and LL. So our upper limit is going to be 0.60 plus 0.05. What's our lower limit? That's 0.60 minus 0.05. So when we do that, here we're going to get 0.65, and here we're going to get 0.55. Okay, so does 0.69, turn this into a decimal, right? Does 0.69 lie within this range? No, it doesn't. 0.69 is somewhere here, right? It's above this, right? So let me just draw this up really quick. If this is 0.55 and this is 0.65, right? This is where we need to be to say we do not reject. But we see that 0.69 is on this side, right? Just get another color. So 0.69 is somewhere here. So that means we reject. We can reject. Okay, so for number 31, this is asking us what the sample size n would be. To do this problem, we have to use, let's go back to the formula sheet. We have to use this equation right here. So I'm going to write out the numbers that you're going to be putting in. You're going to be putting this in on Excel, and okay, let's just see what happens when we do this. Okay, so the formula says n equals, it's z of alpha divided by 2 squared. This value going here is our critical value. So this means it's our critical value squared. So what was our critical value? That's this number right here. So it's going to be 1.64 squared. Then you're going to multiply p times 1 minus p. So what is p? That's going to be 0.6 times 1 minus p, 1 minus 0.6. And we're going to divide that by the margin of error. And the margin of error is 0.1, and we need to square that. All right, so if you were to plug this into Excel, you are going to get 64.933. But whenever we're trying to do these problems, we're always going to be rounding up. So even if this was 64.1, we're just going to round up whenever we're trying to figure out the sample size. In this case, it's 9, so you'd round up anyways. But all right, so the answer is going to be 65. And so there we go.